let's get started. So what I'm going to cover today are really a couple of key questions related to interoperability. First off, what is it? Secondly, why is it important to transportation? From there, we're going to get into kind of how cities can make it real, how cities can become more interoperable. And then lastly, I'll close with some context for how GTT can help. So first off, what is interoperability? As defined by Wikipedia, interoperability is the characteristic of a product or system whose interfaces are completely understood to work with other products or systems at present or in the future in either implementation or access without any restrictions. Okay, so a lot of words there, but there are a couple of common themes that are key themes that I highlighted. The first is the interfaces are completely understood. What that really means is the interfaces must be documented and documented in a way that companies and partners outside of the individuals that document it can understand it. And the idea then is that by documenting it in that way, companies, agencies, departments can pick that document up and figure out how to interface to that system. Okay, the second piece is present or in the future. So with interoperability, interfaces are typically the key to that. The point being, the interface doesn't necessarily have to be used today. It has to exist with the thought that it can be used today or potentially it could be leveraged in the future. And then the last piece here, without any restrictions. That does get a bit gray in this world of kind of competitive capitalist economy. But at the same time, it is an important one. So the way I would phrase this is the companies that are essentially requiring interoperability must be able to have limitless access to that interface and that interoperability documentation. Without that, they really can't make the systems work and coincide. Okay, what interoperability also allows is companies in a capitalist economy to compete and coexist. So I'll give you a little context here. It really is the underlying principle to allow competitors like Apple and Google or Alphabet and Microsoft to not only compete to be the world's largest company, but also to offer solutions and products that can coexist within each other's platforms. Interoperability is also the underlying theme to allow competitors like Siemens and Philips and GE in the healthcare space to leverage standards like DICOM and HL7 to communicate to electronic medical record systems or hospital information systems. Ultimately, what that does is it allows the market to have choice, and it also creates competition. So in the end, what interoperability really allows is the ability to exchange data across systems. So why is interoperability important to transportation? Okay, the first is urbanization. I'm sure many of you have heard the trends or read the reports about what the U.S. is expected to go through over the next 20 years in terms of population growth, but there are really a couple aspects to this. There's the rapid population growth by 2045, but then there's also a move of individuals from rural to urban areas. This is obviously going to create tremendous congestion in cities, and these cities are, one, budget limited, but they're also land and space limited. And so what that means is they need to find smarter and more efficient ways to use their existing infrastructure. Okay, interoperability is also important because of the rapid movement of technology. And so before I jump into this, I want to highlight that word movement. Movement really means a couple things. The first is the technology itself. Is the software, the hardware, the mechanical devices, is the solution available technologically for the market to use? And then the second piece to this is adoption. Is the market really at a point where they're ready to adopt this technology? And so I'm going to run through a couple of scenarios that paint this picture. So the image that I have on the screen here, from 1916, a device or a contraption called the AutoPed was patented. You'll notice something about that AutoPed. It looks a lot like the scooters that we see parked in and around urban streets. But this was 100 years ago. And so what happened over the past 100 years that made scooter shares now all the buzz today? because I don't recall these 20 to 30 years ago when I was growing up. Fast forward 2001, the Segway was commercially released. Again, a lot of technology incorporated in this system. But as you all would recall, we don't see Segways in and around our streets. They're not a standard way for people to get around. They're more of a niche for tour guides and travel agencies to use to allow people to see cities in a more efficient way. Okay, trace this along a little bit further. 2017, 2018. In 2017, Lime was founded, scooter share company. Less than a year later, that same company was valued at $1 billion. Notice the look of the individuals riding that scooter compared to what existed 100 years ago. One would argue that the technology existed 100 years ago, but what didn't exist is the need and the adoption of that device. And now those two things are essentially aligning to ultimately address a major need in cities. Okay, I'm going to take you through one more of these. So in 1999, FCC allocated spectrum in the 5.9 gigahertz range for intelligent transportation systems. Okay, so about 20 years ago. 2015 and 2016, the US DOT announced and awarded funding for the Smart City Challenge, as well as 3 primary connected vehicle pilots. The funding and these pilots were both largely based on technology leveraging that 5.9 gigahertz spectrum. Continue this out. Later in 2016, a group called 5G Automotive Association was formed, largely around the idea of providing connected vehicle applications over cellular communication networks. A little bit different than leveraging that 5.9 gigahertz spectrum for ITS. In 2017, GM releases DSRC technology in one of their Cadillac models. That DSRC technology leveraged that 5.9 gigahertz spectrum. Okay. Later that year, the 3GPP group released the standard for cellular V2X, again, competing in a lot of ways with that 5.9 gigahertz spectrum for DSRC, offering a lot of the same applications, but using the cellular technology. In 2018, Toyota and Lexus, as well as a couple of other major auto OEMs, announced that they were going to support DSRC in their future vehicles in early 2020s. But then later 2018, Verizon and AT&T announced the initial rollouts of 5G cellular networks in select cities. Fast forward now to where we are today. A month ago or so, Toyota announced that they're pulling DSRC from their roadmap. And they're aligning more directly with cellular communication within their vehicles. And so you look at what happened over the course of this technology, not a lot happened, and when I say not a lot happened, I mean commercially. I think a lot happened by way of standards between 1999 and 2016, but commercially, the technology that was really driving DSRC and connected vehicles didn't change a lot. And it wasn't until the last 3 to 4 years that this technology and connected vehicle applications have really started to come into their own. And it's starting to add a lot of dynamics by way of auto OEMs and technology providers trying to decide what to do in terms of solutions they should provide to their customers. Okay, so the beautiful thing about interoperability, however, is that it enables choice, it enables longevity, and it also allows for an evolution of technology. So what can cities do to deploy more interoperable transportation systems? At the highest level, they need to understand and evaluate their transportation ecosystem. And I frame that up in really 4 key areas. The first is, with their onboard vehicle systems, what technologies do they have today? What do they look to deploy in the future? That's things like onboard computers, maybe you have some advanced vehicle locating technology, maybe you have preemption or priority control. There's a whole host of technologies being deployed on buses and fire trucks and passenger vehicles. From there, you can look at the intersection equipment. What do you have for signal controllers? What brand, what models, what standards do they align with? Also, connected vehicle technology like preemption priority control, vehicle detection, cameras, those types of equipment. You can also look at your control center, kind of your back-end areas of your business. So what do you have within your traffic management center? Do you have an advanced traffic management system? What hardware and software IT systems are in place? Are you leveraging cloud versus on-prem IT environments? And then another big one, as you start to move into the world of connected vehicles, is communication networks. Do you have fiber? How wide is that fiber deployed? Do you have wireless networks? What wireless networks do you have in place? And then what are you looking to do in the future? And so within each of these transportation areas, there are underlying standards that kind of drive interoperability within these spaces. So on the vehicle side, there are standards like J1708, there are CAN bus, there are standards around geolocation, specifically with GPS and GNSS, and then there are also standards in terms of system I/O, even going as far as aligning on 12-volt versus 24-volt power distribution. On the intersection side, you have standards like NEMA, TS1, TS2, NTCIP, and then even technology protocols like SDLC. In the control center, you start to get into the networking world and the IT world. You have communication and technology standards like MQTT and HTTP. These are frameworks to drive communication across systems. And then data sharing like XML or JSON. And then lastly, on the communication networks, there's cellular communication, there's Wi-Fi. DSRC is a standard. GTT currently offers a 2.4 gigahertz standard that's widely deployed across the U.S. And then there are also optical solutions and a host of other solutions that have been used for communication over the last 20 to 30 years. Okay, so there's really a lot when you start to think about standards. What I want to do today is really highlight some of the key standards to consider in transportation, and really specifically around traffic systems and connected vehicles. So on the traffic system space, the key standards, which I'm sure many of you are familiar with because these are not new, but I think it's important to highlight because you start to think about the next wave of connected vehicles. It's these standards that will evolve and these standards will change. And so it's going to be important for you to understand what these standards mean so that you can align your city and your infrastructure to work with future technologies. So there are the NEMA, TS1, and TS2 standards, which really align or assign the traffic control systems, specifically equipment in the cabinet, the operational and environmental requirements, what interfaces are required to connect those devices in the cabinet. The ATC spec, our standard, specifically ATC 2070 standard, which really defines the advanced traffic controllers, specifically components, wiring, mechanical, and interfaces. And then as you start to think about how do you start to effectively and in a standard way interact with traffic size systems, there's a host of NTCIP standards and frameworks that you can turn to. There are a couple of specific ones that relate to connected vehicles, 1211, which is specifically around signal control and prioritization, and then 1202, which relates more to configuration of traffic controllers, but that starts to blend into how you configure to align with connected vehicle applications. Okay, so on the traffic system side, those are the key standards that you're going to want to be versed with as you start to think about what do I want to do within my city for interoperability. On the connected vehicle space, it starts to look outside of that traffic world and into the vehicles and what standards are necessary to bridge those systems. The first is SAE 2945. This is the DSRC system engineering process. Really calls out system definition for DSRC as well as the generic communication guidelines to use that technology. There's also SAE 2735. This is the DSRC message set. So it calls out specific applications that I'm sure you have all heard or read about. It also defines the message format. Now, these messages should be structured so that a message can be sent from an onboard unit within the vehicle to a roadside unit at the intersection. And then it gets into some operational aspects of how the applications work. Okay, and a new standard, and when I say new, it was rolled out in 2016, but it's very quickly evolving, is the 3GPP technical specification that defines cellular V2X. So when you think cellular V2X, think essentially the connected vehicle applications that have been discussed and shared and demonstrated leveraging DSRC technology. It's essentially doing the same types of applications or offering the same types of applications over cellular networks. So 4G today, 5G in the future. Okay, so the key takeaway to all of this, I'm not going to deep dive into any one standard, but what I want you to do is just be aware of the standards and where they exist specifically as you think about kind of interoperable transportation systems, and understand that if you want to deploy a smart city, you really need to consider your current and future systems as well as the standards that are incorporated within them. Okay, so last section here, how can GTT help? So GTT has a deep history, over 50 years of experience in the connected vehicle space, specifically preemption and priority control. You can see here our vast array of customers. We work with customers of all shapes and sizes, literally, across the US, Canada, as well as the world. And so as you can imagine, standards play a huge role in what we deploy because no two cities are alike, and there's varying degrees of infrastructure across all of these cities. What I want to do is show you a little bit of perspective, or give you a little bit of perspective on how GTT has incorporated standards in our connected vehicle architecture. So I'm going to take you through a little bit of a technical description of how our Opticom systems work in the devices, but I'm not going to go into all the detail. Again, if you are curious about any of the elements that I talked through here, we're more than happy to have a follow-on discussion with you. But what I want to point out here are the key areas of interoperability. So in this first row here, you'll see Opticom IR. This technology has been around for 25 plus years. Okay, so you have essentially a device on the vehicle talking to a device at the intersection using light, essentially, and then that communicates to a device, a piece of equipment that we have within the traffic cabinet called a phase selector. That phase selector is compatible with essentially 90 to 95% of the traffic controllers in the market. And the reason that is because it leverages NEMA standards for connectivity to those controllers. It uses a NEMA standard interface for both TS1 and TS2 cabinets. And that is really what allows us to be compatible with the vast array of traffic controller manufacturers in the market. Okay, we're going to carry this up. Opticom GPS operates similarly, where we have a vehicle device that communicates to an intersection device. In this case, though, it's a little bit smarter in that it uses GPS or geolocating on the vehicle, and it passes that geolocation information to the intersection. And it passes that information via a radio, so you don't run into line of sight issues and those types of things. But then ultimately, that information gets to our 764 phase selector. That information, again, can be passed to traffic controllers using that NEMA interface. Or what we've added is the ability to send that information to controllers via NTCIP. And so what that really allows is as cities start to look at doing advanced kind of traffic operations, so adaptive signal timing or dynamic signal timing, they're going to need more information than just give me preemption now, as an example. They're going to want information like how far out is the vehicle from my intersection? What's its ETA? What's its ID, as an example? They're going to need that information so that they can adjust their traffic timing to accommodate that vehicle. So we've incorporated NTCIP standards into our phase selector interface to the controllers to allow that. Okay, I'm going to continue this forward. What we've also done is we've standardized interfaces on both our vehicle kits as well as our intersection equipment to leverage cellular communication. There are specific underlying technologies that we've aligned to do that, but ultimately the takeaway is that now if a city has cellular communication either on their vehicles or at their intersections, we can now plug into that as a mechanism to communicate from the vehicle to a back-end system or ultimately to the intersection. And then similarly, more and more cities are starting to deploy fiber across our city connected to a traffic management center as an example. Now, when you have cellular communication as well as a fiber network, you now have completed kind of a closed loop communication path from a vehicle to an intersection without any additional hardware either at the vehicle or at the intersection. So GTT can actually deploy software-based solutions that leverage that hardware. That hardware can be a GPS system, it can be a computer, ideally like a Windows-based or a Linux-based computer, connected to a cell modem, 3G, 4G, eventually 5G. And so now that's less infrastructure that the city has to purchase to deploy this system, less infrastructure that the city has to maintain, and it ultimately speeds up the deployment process because of that. And then ultimately you've invested a lot of time and effort and money to deploy fiber. You'd want to get more out of that. There are mechanisms to do that now by forcing interoperability to your customers. And then the last one, just to bring some visibility to DSRC. In the DSRC world, for those of you that are looking to deploy that infrastructure, you would have an onboard unit, much like Opticom GPS. You would have a roadside unit at the intersection, again, much like what we have in our Opticom GPS system. And then that would leverage standards, NTCIP based in most cases, to communicate to the traffic controller. So again, you have this ecosystem where now the agency, the department, the city has the power to choose which manufacturers they want to partner with. That can be feature-based, that can be price-based, that can be technology evolution-based. And now you can choose and mix and match different manufacturers in different parts of your system. And so you can essentially create an ecosystem that can evolve and stand the test of time. Okay, one other area just to give you perspective on GTT and where we stand. We are definitely committed to standards evolution. So we're actively involved in connected vehicle standards groups. Society of Automotive Engineers, SAE, is one of the driving kind of governing bodies for those standards. We hold review and voting membership on multiple DSRC and 5G V2X task force groups, as well as the NTCIP 1202 working group. We're actively involved in ITS America. We continually present on panels. We also do demos at their shows. So we're very active there. You start to think about things like advanced technology, things like DSRC. Again, we regularly demonstrate our ability to leverage these technologies and incorporate them in and around city infrastructure. I think that's an important piece as you start to adopt and prove out kind of your path forward. And then lastly, in the development space, we have our own kind of connected vehicle lab where we're testing out the latest advancements in DSRC as well as cellular V2X to figure out what are the right technologies to deploy for our customers, understanding the full ecosystem. And then we're actively engaged in pilot opportunities around these technologies. So if you are a city, you're interested in a connected vehicle application, you have questions about your current infrastructure and how do you migrate over time, or you're looking at some new applications, GTT is more than happy to follow up with you to learn a bit more about what you're looking to do, and then ultimately carve out a pilot project if that makes sense. All right, so the key takeaway here, GTT has market-leading expertise in interoperable mobility solutions. All right, so that concludes the core content that I wanted to cover today. So to bring it all together, do a quick recap. So interoperability is the ability to exchange data across systems. Interoperability enables choice, longevity, and evolution. You're going to want to consider your current and future systems when choosing a solution today. And lastly, GTT has market-leading expertise in interoperable mobility solutions. So with that, I want to thank you for your time. I want to turn it over to Lauren for any questions.
Awesome. Thank you, Chad. So like Chad said, we're going to go ahead and take some time for questions. Just a reminder, please be sure to type your questions into the question box in the control panel to your right. We do have a few questions. Chad, it looks like you might have covered some of this, but I'm going to review the questions in the order they were submitted. So the first one we have here is, there is a lot of development and piloting taking place in the market around connected vehicle deployment. Do you have any examples of customers using traffic or connected vehicle standards in a fully operational environment?
Yeah, that's a really good question. Interesting one. So yeah, while connected vehicle gets a lot of attention as a buzzword today, connected vehicle really isn't new. I talked a little bit about preemption and priority control, and that technology being around for over 50 years or being available for 50 years. I can point to some of the key standards again on the NEMA side, TS1 and TS2, leveraging those standards within the cabinets to interface, say, a connected vehicle solution from GTT with the traffic infrastructure and specifically the controllers. We also have deployments currently underway and solutions in place today where we're leveraging NTCIP, so specifically NTCIP 1211 and 1202 to do preemption and priority control. Again, it's to get into the world of kind of advanced traffic operations, adaptive signal timing, but it's also to align ourselves with cities that are updating their infrastructure to advanced traffic controllers. So those are in place today.
Great, thank you. And then the next question actually goes along with this first one very nicely. So this next one is, where can I learn more about connected vehicle standards?
Yeah, so the easy answer to that is Google, obviously. But each of the main standards boards, so there's NEMA, there's ITE, there's AASHTO, they all have their own sites that will direct you to their standards that they manage. They oftentimes collaborate on these standards, but there's typically one keeper of the standard. So you can go to those sites directly. But another valuable resource is actually on the US DOT website. They have essentially a connected vehicle or ITS area. And so if you just search US DOT connected vehicle, they have a wealth of information on their website around the DSRC technology, DSRC standards, but then they also call out a number of the applications that are being discussed in the connected vehicle world. The one caveat or the one caution I would note is that while the applications on that site will be presented as if they're only kind of viable during using DSRC, I will say those are the same applications that are being essentially evolved or adopted to the cellular V2X space. Okay, so it's important to think applications are separate than the actual communication technology that are going to be used or deployed to connect things.
All right, we had another one come in. So this one is there any work towards integrating Opticom with computer-aided dispatch at the public safety answering point, or 911? The ability for Opticom to help navigate first responders to the location of the call would be of incredible value.
Yeah, that's a great question. I need to think about the right strategic way to answer this. The first thing I would say is yes, and the overarching aspect to that yes is we are spending tremendous time and effort in our development currently to make Opticom more interoperable in general. And so that's not just with CAD systems. We've done a lot of work, or public safety CAD systems. We've done a lot of work on the transit side, largely by need, to integrate Opticom within CAD systems on the transit side. So as one could assume, we're doing the same on the public safety side. So I will say there are a number of initiatives within GTT today that we're driving to do just that. So the short answer is yes. The second piece to this, based on your question, is around incorporating routing into Opticom. One of the things that we take pride in and we've really held tight to in terms of how we leverage Opticom is not being route specific for Opticom, understanding that it's common for first responders to have to deviate from a route. We don't want to be completely tied to a route as core to function for Opticom. We want to allow our public safety first responders to be able to go off route and still use Opticom. So today, Opticom works independent of route. With that being said, getting route information into Opticom will allow us to incorporate kind of smarter preemption and more look-ahead type preemption as you start to move in adaptive and dynamic signaling, when you start to get information to controllers sooner and clear cues and those types of things. So as we look to refine Opticom, that's certainly one of the areas that we're evaluating.
Great. Well, it looks like we've covered all of our questions. Chad, is there anything else you wanted to cover before we wrap up?
No, again, I just want to thank you all for your time today, and as I mentioned, I want to stress, if you guys do have questions about interoperability and technology, I know we're your customers, most likely of us already today, and we're more than happy to have a follow-up discussion with you. So thanks again for your time.
Great. Yes, as Chad said, thank you everybody for attending. We really appreciate you being here, taking time out of your day. Again, we will send out the recording and related content tomorrow, but if you have any further questions or interests, we do encourage you to contact us directly, and we will arrange a time to speak to a GTT resource. So thank you again for joining us today, and have a great day.